Now we just import data sets, and now we are going to import the NumPy module for our second method for checking any kind of data problems outlier. Basically in NumPy we have a method, as we already studied in analytical methods, percentile. So we are going to use those concepts for identifying, or you can say uh, improve the data sets through this concept. Like we already discussed about the data we will going to use DC. So basically in income we have different values out there, like 1000, 4000, and if we check that what is the maximum, or you can say 75% of our data, and what are the you can say different percentage, we can actually check through percentile. So if we just type np dot percentile DC, and the name of my column income, and at which you can say how, at which particular percentage you want to check the value. Like we are going to check the 75, or you can say 99 percentage at this position to which particular value lie, so that we can able to check the 100th percentage value, that how are the values relate with each other. For example, if we just look at the 99th value, so we can able to predict that the 100th value is how much far away from this 99th value, so that we can able to predict that this when we consider it as an outlier, and we can actually remove that one. So we can also check through this through 75 percentage, or you can say 85 percentage, on the basis of those two values. uh, we can predict the outliers, but for our easiness we will consider the 99th one, because obviously we don't need to you can say drop most of the rows through this concept. If we just consider 75, or you can say uh, 85, so obviously above than 85%, so there are multiple values are there, and we have to drop those values. But we don't need to drop all those rows. We can be able to we can say change those rows into our own respect. So I just executed, and now you can check in a DC in column name income, and we have to find that all the values which are greater than this values would be equals to this values. So we have to save also this value inside that DC column. So for that you also provide this DC dot income here, and then inside this large bracket you have to provide this concept, and this means that the value you're gonna find DC dot income greater than this value, so it will provide the values, and those values which is inside this data dot income will gonna replace with the this value, which is 778 7878. So as I already executed, so if you look at the values, so here you can check before this we have find that in the fifth or sixth row we have a value of almost 10 lakhs, and now if we look at the sixth fifth row we have find this values. So for outlier you can actually remove this outlier through this concept and improve your under data for the further analyzations. You also remove your lowest number, because this 85 or 95 or 99 means that the value which is at the higher extreme positions, but it is possible that your outlier also light at the very minimum position. And if you look at your data first, so there is a average value which is we already find that the average value what, well, this is the almost 1.15 and exponent something like that, because the outlier also contains, so the average also error based. So if you find our uh, like DC again, because we already improved this. Equal dot describe. Now our income become means of income become 3968, and this is a good thing, and our maximum is this one. This is the understandable data, and I hope it will not gonna provide your error results. But it also contains some problems here, like if you look at your minimum value, which is 1, and your average value is 3968, so obviously this is a very big difference again. So how you remove this problems, like if you look at your data, so there is a value like 3 1 3 5. It's possible that due to some errors it contains some unusual values here. So how you remove it and to replace with the average value, as we understand how you replace your average value with a particular number. Oh, sorry, your minimum value with a particular average number. So for that you already do this thing, like you just copy this thing and paste here. Okay, and this is UV mean upper value, but now we need to look at the lower value. So we have the this lower value number here, LV. Okay, so if we want to check the lower value, so obviously we can't use this higher percentage number, but the lower percentage number. For example, if you want to check at the uh, 5% of your data at which positions lie, so just check it and save this inside this LV variable, and after executing this LV in the next row, so you can find as this is the 3% of your data of income data lied at the 3 position, 3 numbers, and this is very far away from your average mean. So if you want to check that your 10% data lied at which number, so for that you can check 3.6. This is also very huge differences if you look at the 20% of your data. So let's check. So 20% of your data is almost nearer to your mean. So if you check your 50%, 15%, example, 15% is also 16%. 16% is something greater than 15%, and if you look at the 17%, 17% is also greater than something, and then if you look at the sorry, 18%, for example, I think it will be a great for us. So I think 19% would be good for the minimum value that could be placed at the minimum values like 3, 4, and something values which can gonna actually replace with this number. So for that you just need to follow the same step which we actually did before, just copying that thing, like just copying this line here and just editing, applying some this line like dc dot income. I change with LV, and obviously all the data value which is not greater than up right now we not need to use this concept like lower than. It means that all the values in our data income data set, sorry, income column, which are lower than this lower value, which is 2006, would be replaced with the this LV value. It means that the minimum value what 3, 4, 5, 306, 309, and all these values gonna replace with this 200, 2006. Just execute this, and now if you look at your data, so you will find that your overall data become very smooth. It looks good actually. Okay, so if you find the describe function here and I'll check all the descriptive statistics, so what will happen, let's check. Now your mean becomes 4339 and your 50% of your data also nearer to your mean. How you check this thing? Like obviously our 50% of data should be tell about our mean. Okay, that's why this is, and this is very near it. And if you look at before what there, like your mean is 3968 and your minimum value which is 43, it will almost a difference of 400 differences are there. And if you look at your the previous one, so your mean becomes almost 1.15 and exponent is almost like 15 lakh something, and this is the 43 lakh. So this is very huge differences. How you resolve these things you just learned here. So hope you understand this concept, outlier concept in data cleaning concepts. And I hope you will gonna try by yourself as well with your data, and any particular value which is not good for your data, so you can remove or you can replace with your average value or with your particular number through percentile concepts, like as we did in the video, like percentile, how you can check at 99 and 19% of your data is this, and then you can replace with this by all the value which is very near to zero or something very small, so you can replace with this concept. And the higher one which you already did, you can also follow that step.